Imagine drifting through the infinite expanse of the cosmos, your gaze fixed on a distant star, its light an ancient whisper from billions of years ago. Suddenly, a subtle shadow crosses its face, a fleeting dimming that hints at worlds unseen, orbiting in silent grace. What secrets do these hidden realms hold? Could they harbor oceans teeming with life, atmospheres ripe for breath, or landscapes waiting for footprints not our own? What if, among the trillions of stars, another Earth beckons, challenging us to redefine our place in the universe? Welcome to the thrilling quest of how do we find habitable exoplanets. A journey where science pierces the veil of the unknown, revealing the potential for life beyond our blue marble. In a world grappling with overpopulation, climate change, and the fragility of our biosphere, the search for habitable exoplanets isn't just astronomical curiosity. It's a profound reflection of humanity's enduring hope for survival and expansion. This topic strikes at our core, fueling the age-old question, are we alone? It connects personally by mirroring our own planet's vulnerabilities, inspiring technologies like advanced telescopes that could one day detect Earth-like worlds, potentially guiding future migrations or resource strategies. As we face environmental crises, understanding habitability elsewhere sharpens our stewardship of Earth, while breakthroughs in detection methods propel innovations in AI, spectroscopy, and space travel. For dreamers and realists alike, it promises a future where humanity might seed new homes among the stars, transforming abstract stargazing into a blueprint for interstellar destiny and reminding us that our curiosity could unlock the keys to cosmic belonging. The dream of other worlds traces back to antiquity, when ancient philosophers gazed at the night sky and pondered plurality beyond Earth. In the 4th century BCE, Greek thinker Epicurus speculated on infinite atoms forming countless worlds, while in the 16th century, Giordano Bruno envisioned an infinite universe teeming with inhabited planets, a heretical idea that led to his execution. Medieval scholars like Niccolò Resme debated multiple worlds, blending theology with early cosmology. The scientific pivot came in the 18th century with Immanuel Kant's nebular hypothesis, suggesting planets form from swirling disks around stars. By the 19th century, astronomers like William Herschel hunted for planetary signs, though technology lagged. The modern era dawned in 1917 with Adrian van Maenen's detection of a polluted white dwarf, later recognized as exoplanet evidence in 2016. True breakthroughs arrived in 1992, when Alexander Wolfson and Dale Frail discovered the first confirmed exoplanets around pulsar PSRB 1257+12, rocky worlds orbiting a neutron star corpse. 3 years later, Michel Mayor and Didier Queloz announced 51 Pegasi b, the first around a sun-like star, earning them the 2019 Nobel Prize. This timeline, from mythical musings to empirical triumphs, illustrates humanity's relentless pursuit, evolving from philosophical whispers to telescopic revelations that redefine our cosmic narrative. Uncovering habitable exoplanets relies on ingenious methods that decode stellar secrets, explained through everyday analogies to make the cosmos approachable. At the heart is the habitable zone, the Goldilocks region around a star where temperatures allow liquid water, neither too hot nor too cold, like finding the perfect spot by a campfire. Primary techniques include the transit method. Imagine a moth fluttering before a lamp. As an exoplanet crosses its star, it dims the light periodically, revealing size and orbit, used by Kepler and TESS to spot thousands. Radial velocity, or the wobble method, detects a star's subtle tug from planetary gravity, like a dog pulling on a leash. Doppler shifts in starlight measure mass and orbit. Direct imaging captures planetary glow, challenging due to stellar glare but aided by coronagraphs, akin to blocking the sun to see a firefly. Gravitational microlensing bends light from distant stars, magnifying hidden planets like a cosmic lens. For habitability, spectroscopy analyzes atmospheres for biosignatures, gases like oxygen or methane, while density calculations, mass over volume, distinguish rocky from gaseous worlds. These principles, grounded in physics and optics, empower even novices to grasp how we sift through starlight for life-bearing gems. The hunt for habitable exoplanets has unfolded through electrifying revelations, each a seismic shift in our cosmic worldview, building like a cosmic thriller from doubt to dazzlement. For centuries, planets beyond our system were myth, until 1992 shattered the silence with PSRB 1257+12's pulsar planets, exotic but uninhabitable. The plot thickened in 1995. Michel Mayor and Didier Queloz, unveiled 51 Pegasi b, a scorching hot Jupiter, proving sun-like stars host worlds and igniting the exoplanet boom. NASA's Kepler mission, launched in 2009, revolutionized the field, detecting over 2,600 planets via transits, including Kepler 452b in 2015, an Earth-like world in the habitable zone dubbed Earth 2.0. TESS followed in 2018, scouting brighter stars and uncovering TOI 700 days in 2020, an Earth-sized, habitable candidate. The James Webb Space Telescope's 2022 launch escalated the drama. In 2023, it probed K218b's atmosphere for dimethyl sulfide, a potential life sign. By 2025, JWST confirmed biosignatures on K218b and unveiled LHS 1140b, a super-Earth with possible oceans. TRAPPIST-1's 7 rocky planets in 2017, 3 habitable, and Proxima b's 2016 discovery near our stellar neighbor fueled suspense. These milestones, from pulsar oddities to atmospheric whispers, have transformed skepticism into a catalog of over 5,900 worlds, forever expanding our hunt for cosmic kin. Get ready for cosmic jaw-droppers. These lesser-known truths about habitable exoplanets will redefine your starry-eyed wonder. First, rogue planets, untethered from stars, roam the galaxy in billions, some potentially habitable via internal heat or thick atmospheres like interstellar nomads sustaining hidden oceans. Shocking, WASP-12b rains molten iron, while HD 189733b's glass storms shred at 5,400 MP8, extreme worlds highlighting habitability's rarity. Lesser known, Kepler 442b scores higher than Earth on habitability indices, with optimal size and starlight for super-habitable conditions. Jaw-dropping, 1 in 5 sun-like stars hosts an Earth-sized habitable planet, implying trillions galaxy-wide, yet we've imaged fewer than 50 directly. Another stunner, TIC 241249530b's egg-shaped orbit swings from freezing to scorching, testing habitability's edges. Finally, some exoplanets like 55 Cancri e boast diamond layers from carbon pressures, celestial jewels uninhabitable, but mesmerizing. These revelations aren't trivia. They're windows into the universe's wild diversity, challenging our Earth-centric views. Now let's ignite the imagination with theories where exoplanet science dances with speculation, pondering futures that blend discovery with destiny. What if we detect biosignatures on a habitable world? Could microbial life evolve into intelligent beings, sparking interstellar communication via laser signals? Envision superhabitable planets larger than Earth with milder climates, hosting biodiversity explosions. Bold question, might they outshine our world for life, drawing future colonists? In one scenario, advanced telescopes like the Habitable Worlds Observatory reveal oceans on rogue planets, sustained by geothermal energy, expanding habitability beyond stars. What if climate models predict Earth-like atmospheres on tidally locked worlds, with eternal day-night divides fostering unique ecosystems? Dystopian twist. Discovering uninhabitable Earth twins ravaged by runaway greenhouses warns of our climate fate. Ethically, if we find life, do we intervene or observe? Future probes might seed barren worlds with microbes, terraforming them for humanity. These what-ifs weave wonder with caution. Habitable exoplanets could herald unity through shared discovery, but at what interstellar cost? The quest for habitable exoplanets transcends telescopes. It's a mirror to humanity's soul, shaping our future through inspiration and introspection. Discovering Earth-like worlds could redefine existence, offering backups against existential threats like asteroids or climate collapse, potentially enabling interstellar migration. It impacts us profoundly. Exoplanet tech advances medical imaging and AI, while fostering global collaboration in missions like JWST, uniting nations in cosmic pursuit. Emotionally, it stirs awe, combating isolation by hinting at universal kinship, and philosophically challenges anthropocentrism. Earth's rarity amplifies environmental urgency. For survival, it drives sustainable tech. Imagine adapting alien habitability insights to terraform Mars. Yet, it evokes humility. If life abounds, we're stewards of a precious speck. If rare, our responsibility magnifies. This search connects us, igniting dreams of starfaring legacies and reminding that in exploring others, we better understand ourselves. Visionaries across eras have illuminated the path to habitable exoplanets, their words blending poetry with prophecy. Carl Sagan mused, "The cosmos is all that is or ever was or ever will be, urging us to seek life amid its vastness. Michelle Mayer reflected, "We are not alone in the universe," on discovering 51 Pegasi b, sparking the habitability hunt. Stephen Hawking warned, "To confine our attention to terrestrial matters would be to limit the human spirit," advocating exoplanet exploration for humanity's future. Sarah Seeger, exoplanet pioneer, declared, "We need to widen the habitable zones seen around alien stars," expanding our search criteria. Jill Tarter of SETI pondered, "How arrogant it is to think we're the only ones," emphasizing biosignature pursuits. These insights, authoritative yet evocative, inspire our quest, fusing intellect with the human yearning for cosmic connection. From ancient starlit dreams to JWST's spectral whispers, our odyssey into finding habitable exoplanets has charted a path through history, science, and speculation, unveiling worlds that challenge our solitude. We've demystified detection methods, celebrated breakthroughs, and pondered futures teeming with possibility. Yet as we peer into the abyss, one enigma endures. If habitable havens await, what stories might their inhabitants tell of us? The universe isn't a distant void, it's our extended home, binding us in stellar wonder. Perhaps the greatest discovery isn't another Earth, but realizing our own is worth preserving amid the stars. Thank you for this stellar voyage. What worlds will you imagine next?